you take one sip of a sugary drink, and your body can begin responding before you even realize what's happening. But here's the surprising part. Your pancreas doesn't simply wait for your blood sugar to spike. Deep inside it, a chain reaction is already beginning. So what actually happens inside your pancreas before that insulin surge reaches its peak? It starts with digestion when you eat something high in added sugars like a sweetened drink. Candy or processed dessert carbohydrates are broken down into simpler sugars, including glucose. That glucose is absorbed through your small intestine and enters your bloodstream. Blood glucose begins to rise and deeper inside your abdomen. The pancreas is part of the system responding to that changing metabolic environment inside. The pancreas are tiny clusters of hormone-producing cells called the islets of Langerhans, and within those clusters are beta cells. These are the cells at the center of the insulin response. As glucose becomes available, beta cells take it up and metabolize it. And now something fascinating happens inside the beta cell. Glucose metabolism increases the amount of ATP, the cell's usable energy signal. That changes the activity of specialized potassium channels. In the cell membrane, the channels close. The electrical state of the cell changes. The membrane becomes depolarized. Then, voltage-dependent calcium channels open. Calcium flows into the beta cell, and that calcium signal triggers insulin-containing vesicles to move toward the cell membrane. Then comes the release. Insulin enters the bloodstream. What looked like a simple sugary snack has just triggered a carefully coordinated cellular sequence. But there's another part of this. It is insulin secretion. Isn't simply a switch that turns on after blood glucose reaches its highest point. Signals associated with eating, including signals from the gut and nervous system, can contribute to an early insulin response. In other words, your body can begin preparing for incoming nutrients while the meal is still being processed. So the process isn't simply sugar rises, then insulin follows. Multiple signals are working together. Now follow the insulin. Once released into the bloodstream, it travels toward major target tissues, including your muscles, liver, and fat tissue in skeletal muscle and fat cells. Insulin helps move GLUT for transporters toward the cell surface. This increases the cell's ability to take up glucose from the bloodstream. The liver responds differently. It can take up glucose and store it as glycogen, helping regulate how much glucose remains circulating in the blood. So the goal isn't to eliminate glucose internal environment within a workable range while nutrients are being processed and stored. But here's where the story gets more complicated. Your pancreas isn't responding to the word sugar. It is responding to a changing metabolic environment. How much glucose is entering the bloodstream? How quickly it's entering? Signals from the digestive system, signals from the nervous system, and how sensitive your tissues are to insulin can all influence the response. That's one reason to people can eat similar foods and still experience insulin sugary. Meal isn't the same thing as chronic metabolic stress. Your body is designed to handle normal fluctuations in blood glucose. The bigger concern is what can happen when excess energy intake and insulin resistance persist over time, when tissues become less responsive to insulin. The pancreas can compensate by producing more insulin to help maintain blood glucose regulation for a period of time. This compensation can help keep blood glucose within a relatively normal range, but the relationship between insulin sensitivity, insulin secretion, and beta cell function is complex and it can change over time. So the next time you see a sugary drink or processed dessert, remember what you can't see. Do you see the food? Your body sees a metabolic signal. Glucose enters the bloodstream. Beta cells detect the changing environment. ATP rises. Potassium channels close. The cell depolarizes. Calcium enters. Insulin is released, and your muscles, liver, and other tissues begin responding. All of this can happen without you feeling a thing. Your pancreas isn't simply reacting to sugar, it's responding to a constantly changing metabolic environment, and that invisible conversation begins long before you ever notice it. You see a sweet drink, your body sees a signal.